In the last session, we talked about different elements of 5G core network, and we also seen how they are different from the 4G core network. We learned what are the new elements that are added in the 5G core and how the responsibilities are divided into the 5G core elements. Now we will discuss network slicing. So, what is network slicing? Well, to understand this, we need to understand current network system first. So today's networks looks like this in the left. We have a basic telecom network system, and on top of this network, we offer services like voice calls and mobile broadband. Now, different type of use cases such as social media or video streaming, downloads, uploads, playing video games, etc. All of such use cases are using these services from the operator. So you can feel that currently most of the use cases are mainly depend on mobile broadband services. However, in 5G, there is a completely new category of use cases. These new use cases are like massive machine type communication or mMTC and ultra reliable low latency communication or uRLLC services, and of course enhanced mobile broadband services use cases or eMBB services. Now, these all use cases have different network demands, and hence all of them require very specific network characteristics. This means our network should be capable to handle those different network demands and performances. To simplify it, just assume that you have one individual network system for each use cases based on their network demands, like you see in the right section. So in 5G, we have one physical network, but we can create multiple logical networks on top of it. These logical networks are known as network slices. And this concept of creating multiple virtual networks on a common and shared physical infrastructure is called network slicing. And each of these network slices can be configured independently, specifically for their use cases. This means you can specify the network demands and their characteristics for each use cases like latency, capacity, coverage, etc. For example, if any device wanted to use massive machine type communication, then it will connect through that specific network slice. And that slice was already optimized for infrequent data transfers, and that also supports capabilities for longer battery life, which is needed for mMTC based services. One slice can be dedicated for mobile broadband services, which will only handle heavy data transfer or high data rates. And there will be one another slice which is focused for low latency communication, like for self-driving cars and robotic surgeries kind of applications. Even based on the requirement, one single UV can also connect to multiple slices at the same time. For example, a self-driving car needs low latency for communication, but it does not need high data rates, right? However, at the same time, some streaming services also getting accessed from the same vehicle. And now that device also need higher data rates for streaming services. And this streaming services is not heavily depend on the latency requirement, but this needed high data rates. So by using network slicing, we can meet both of these requirements on the same common physical network because now they can be served from two different virtual network slices. Each slice here are completely isolated and traffic on one slice cannot interfere with the traffic on the other slice. Means both of our requirements will be fulfilled because device is accessing two network slices from the network for each separate requirements. On a positive note, this concept also supports new technology upgrades as new requirements or new technology can be deployed in different slices in the network, and that will not affect other existing network slices. Network slicing also help in the better security because if some cyber attack happens on one slice, then only that slice will be affected, and there is very less possibility that it is spread to the other network slices because these network slices are isolated with each other. Now let's see how these network slices are managed. First, in the core network, there is a specific function for this called as NSSF or Network Slice Selection Function. This NSSF maintains a list of network slice instances defined by the operators, and it also maintains their resource requirements, which is also defined by the operator. A UE may be configured with a list of subscribed network slices, and it can request to get the access to a specific network slice during the registration procedure. Now, the Access and Mobility Management function, or AMF, will authorize a network slice based on the user subscription data from the UDM or by a query to the NSSF. For example, if a car requests access to the slice for self-driving car, then the NSSF and UDM will work together to authorize it. Okay, so that's it for today. We learned how the network slicing allows multiple logical networks to run on a single physical network, and how each slice can be configured independently to achieve specific network requirements for specific use cases. We've also seen how this whole process works in very brief. In the next session, we will be talking about service-based architecture. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.